world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision,
fair presentation.
All right, hello and welcome everyone. We're about to begin our conceptual model demo and review, and then we will do open Q&A like I said. So to kind of kick this off, I wrote a little about here, which I will read from, so we can check this out. So this is a conceptual model. The positions of the stars are based purely on kinematics. The observer's optical vault defines the limit of vision onto which the star field is projected. So what that means is you can see here that the observer has a limit of vision and the stars are being projected in here. We can take a look at an overview of the star field. So where the conceptualized true positions would be, let's say, you could have a disk of stars going over top of you, rotating, and then that will produce this effect here that you're seeing within the dome. And what you can do is you can change perspectives here. So this is the God's eye view perspective that nobody has. This is what the overview of the conceptual model looks like, but you can go to this observer-centric mode and you could see what the observer sees. And you can have, you can line up north, east, west, south, and all that. And see exactly what the observer sees relative to their latitude. The way that this is set up, it's positioned elevation-wise to your monitor. So like the midpoint of your monitor here for this would be, if we go to the 45th latitude, oops. Then we look up in the middle here, the middle of your screen would be where that 45 is. So there's all proportional scaling throughout that. So we could see different perspectives here, and then we can also toggle different views here. We could see what it would look like on the globe. The globe also uses a hemisphere of vision. This is exactly how it works for, you know, the same way that they would view the heavens. So we have the celestial sphere out here, and we have what's projected into the observer's view here. And then to bring that down to the center of the globe, what they would say when they're referencing the fictitious observer and all that is referenced here. So if we bring what's projected into the observer's field of view down to the center, it'll be projected onto the surface, and you'll see that the GPs of everything will then line up, you know, exactly where they would be. We can go more into that later and show some direct lines and stuff, but you can see conceptually what this is supposed to represent. It represents an observer's hemisphere of vision and how the how the stars are perceived to move within that. And so we'll keep going here. So also there's other projections here. So there's the dual pole projection. So here we have the God's eye view of what the observer would be seeing, and then we can go into the observer perspective here and see what they're seeing. And we see that when something is tracked, like when we'll get into 24-hour stuff here in a bit, but when something is tracked and you change between projections, the azimuth is preserved. So you could see which direction the observer would be facing in their projection. And the way that looks is all dependent on the projection and the God's eye view of it, which we'll get into a little later. So any conceptual model that uses the lat-long graticule is no better or worse than any other projection. So like I said, all of these projections are equivalent. It doesn't matter which one you're taking your God's eye view of. Each one of them represents and shows the correct direction for which you would be facing for everything. And it's internally consistent with that. That's the point of the projection, and each projection has its own way that it handles azimuth preserving. So let's see here. The graticule is an internally consistent and self-referential to a fictitious observer at the center. It is that fictitious observer that binds the 60 nautical miles per degree relationship to the ground positions. And I think I illustrated that pretty well here when we bring the star field to the center of the Earth. We turn off GPs and we just see what the observer would see. So we hop in first person mode. So we've read from the Celestial Navigation Manual several times when they talk about imagine you're at the center of Earth looking up and the stars are on the surface of Earth. So this is what that concept would look like. That's how they relate the celestial and terrestrial sphere one to one together. Okay. The fictitious observer is not mutually exclusive with the conceptual model. Every such model is ultimately grounded in what a single real observer sees in their own hemisphere of vision. The graticule is simply a bookkeeping convention on top of that. So what I mean by that is when we're looking at different projections here, so when we see this God's eye view here, and we look at where the so-called true positions of the bodies are, and that's referencing, where they once were at a 90 degree and then adding sidereal time to them. When we do that, we see here that you could represent this as a disk, you can represent it as uh, a complete shell, but all an observer ever sees at one time is what's in this hemisphere of vision. Nobody sees these true position references all at once for a God's eye view. Everything that the observer experiences exists in here. So that's an extremely important concept to understand what's being shown here. So the Tang sidereal mapping. So this is really interesting. One second, I'm going to get some water here. So a number of months ago, I came across the history of the Chinese and the Jesuits and the Buddhist Japanese people and their interactions. And so what was put forward in there was, two competing narratives. One was that the Jesuits basically gave, improved upon the astronomy and navigation and stuff of the Chinese. And the other half of that narrative is that they were one of the first people to relate an arc in the sky to distance traversed on the ground. So they had what's called a li, and at first the li was represented by a length of shadow at a particular time of year. So they had shadow length tables that they took at different latitudes, and based on how much those shadow lengths change over distance, they came up with latitude and longitude for shadow lengths. But then that ended up proving to be inaccurate because they had basically interpolated what the shadow length should be. They only had done like two actual measurements, and then that wasn't as accurate as they first thought it was. And then that system was revised by a surveyor in the Zing, or I don't know how to pronounce it, but in whatever dynasty. And basically, he surveyed, instead of using rods and chains, he used rods and a rope, and it's the length of this rope over distance that corresponds to the angular change of Polaris over time. And they also had their own form of degrees. So instead of dividing one divided by 360 degrees, they divided one by 365.25, which would be essentially sidereal time. So they had a sidereal angle relationship instead of the conventional one divided by 360 that we're familiar with. But all of these are directly equivalent and proportional. All you have to do is divide one by the other to get the conversion factor between them and then multiply by that. And that will tell you what it is in the normal degrees that are familiar to us. And likewise, we can do the same with the Lee units. So with those units of measurement, we can determine, or we can convert between meters and kilometers and versus what the Chinese were using with the exact identical system of a celestial sphere, observer centric. And then when they would do, it took them about 150 years or so before they accepted the spherical doctrine. They did all this as geocentric flat earthers. There's a book going over the Treasure Fleet expedition where they had already mapped out the north pretty much, and they were trying to get to the south. And so in order to map out the south, they needed to establish the same relationship to the star Canopus that they had done with Polaris, where it changes at essentially 60 nautical lees per degree. Now it's not 60 nautical lees per degree; it's like 315 lees per degree or something like that. But in any case, you get the idea. So they had to go to the south and then try to get under that star, get it at its zenith, and then sail away from it, so that they could determine that same relationship and make it symmetrical. So you can read about that the Treasure Fleet expedition in 1421 to 1425, I believe it was, and read about how they mapped that out. So they did all this under the cosmology of geocentric flat earthers. After the time flip from AD to BC or whatever, uh, they changed their cosmology from flat Earth and flat heavens to flat Earth and curved heavens. So they, kind of pioneered this whole dome of vision, celestial sphere, single observer situation. And then the English came around and linked everything to a central observer in time and made it relative to their meridian or whatever, their prime meridian for Greenwich. So what the Chinese were doing actually is they had a system where they had an observatory in Beijing, and they would take zenith measurements of stars that would go over them, and they would categorize them by the way that they would pulse, flicker, their color, if they were associated with any other stars, like was it a group of three stars, is it two stars pointing in a direction of a third, that kind of thing. So they would make all these notes about these stars, and then they had essentially large star catalogs that described what these stars looked like and when they transited over Beijing. And then when the lads would go out sailing, they had synchronized clocks that they could use through either sand or water clocks, and then they could recalibrate them as needed using shadow links. So they could, once they obtained their local solar noontime, they could recalibrate it, and then after they observed an eclipse, they would take zenith measurements of the stars that were above them, were the same place that they took their uh, measurements earlier in the day to calibrate their local time so that they could get sidereal time and all that and be synced up to their local noon. Um, and then so once they had after the eclipse occurred, when the moon starts to reemerge, they would note what star was above them, and then they could multiply that back uh, uh, to where it was in Beijing and get their longitude difference. So they had their own unique method of doing all of that within their own system. It was all internally consistent, and that method was redone in like 2001 by a professor and his students. They went to 5 locations and came within 1 degree of accuracy, and they suggested that they could have even improved it by doing a couple of other things and whatnot. So it's a method that works. It's the same exact system that they were using. It's internally consistent, and so distance on the ground are all anchored to that to that system here. So we have our own latitude and longitude that's made up of sidereal degrees as well, and then the distances are computed in lees, and then we have the dimensions for the Tang radius. So the Tang dynasty is when that surveyor Zing or Z or whatever did his, he was working for them. So this would be the dimensions of their celestial sphere. So if we move the observer to the center here, oops, no, we want to go.
Oh,
Oh, we're on the
wow.
dual pole. 1 second. 1 second. We want to go to the AE. Okay. So you can see, we'll turn the stars off real quick so they're not in the way. All right. So they have a height and a radius, right? Because it's just a circle on the ground. They have a circumference. There's a celestial arc, and that's relating the distance traversed on the ground to the change in angle of Polaris, which is what they, how they were relating it. And from the celestial theodolite here, let me see. There was this one. 1 second. Cool. Okay. So from the celestial theodolite, we came up with that Euclidean dot product, or I'm sorry, yeah, the Euclidean projection using vector multiplication. So just basically dot products of radial vectors to get the change in position over sky to use Haversine using a sphere of radius 1. So basically just using Haversine with a unit sphere, which when you add up the sum of the interior angles, you don't get any spherical excess. So excuse me. And then so we use that same system of how we did it with that in our thing. So we have a Haversine way to calculate distances. So you could do that here by clicking on the compass. You can click 2 points on the map. Let me change this so you can see the thing more clearly. Blank. We'll turn off the Tang dimensions. Okay, so we also calculate distance through central angle theorem too. So you can see what that looks like. It'll always link it to whatever the center projection is of the map. Oops. It'll always link it to whatever the center of the map is there. So relating the same thing. They're all the same distance. They all have the same central angle. They look different links on projections, but the angle is invariant, and that's the important part. So you can see what all these great circles or arc links look like on the correct projection, or on the respective projection, and when they're correctly preserved. It's hard to see the line here for this one, but it should be squiggling over here. And then I don't know what it'll look like for this one. Yeah, it doesn't display correctly here because this map is actually shorter than the ring around it, so it's kind of off the thing. But in any case, that's what we're looking at for distances and whatnot. And you could also come down here to distance calculator, enter 2 lat long coordinates, and it'll calculate the distance using that Euclidean projection, vector multiplication, and also central angle theorem. So you could see what that is. And central angle theorem just takes the arc length here in Lees and then multiplies that by the radius value in Lees that we have, and that gives you the distance over that arc length. So all equivalent there. And then so yeah, I think that was the big end of it there. So the relationship between how distances are defined are, when it's part of the coordinate system itself, it's internally consistent. So having this distance be, 23,208 leagues isn't any different than having it be 700 or 7,237 kilometers. Because all we did to get the kilometers is divide our circumference by Earth's circumference, and that ratio is a multiplier that you use to multiply by our distance value here that we would get, and then that will output the conversion to kilometers. And so it's internally consistent in that way. It's not unique to a globe. This is observer hemisphere of vision, uh, basically what it is. And now, when you merge the two hemispheres together and then link it in time to the fictitious observer, like, yeah, you can make this symmetrical coordinate system here all nice and neat and look very globular and whatnot. And that's the benefit of this coordinate system, is when it's all standardized and linked together and everyone's using the same one, well, then everyone agrees on what a meter is. And that's exactly what the board of longitude and what was the other, the board of weights and measurements and all that stuff. That's what the purpose of that was. It was all to bring everything together so that every country would have their own, or not their own, would have a unified unit of measurement to use, because apparently every civilization or country was doing their own relationship on how to define a distance to the angular change of stars in the sky. So there was the stadia. So in order for a stadia to derive the distance for the sun and all that, or I'm sorry, for Earth's circumference and all that, you have to know the distance between Syene and Alexandria. And so to know the distance between them within your own coordinate system, well, when you multiply out the rest of that circle, you're going to get an answer that's internally consistent with the units that you started with. So that's how we, got the same thing with the Lees for a circumference and whatnot. So all of that is internally consistent. So now we'll go over a couple of demos and things. To start us off with, there's a bunch of demos that are featureable here, and I'm pretty sure all of them work. One of the big ones that I would like to show real quick is flight routes. So we often get told that this flight route wouldn't work; it would be too long uh, on a flat Earth. What the heck? Oh, I have flat Earth on dark mode. 1 second. We get told that it would never work. The distance would be too long and stuff. And that's only true if you calculate the distance incorrectly and try to do like straight lines on a Gleason map. And when you read the patent for the Gleason map, its purpose is to preserve the projection of the length of a meridian. And so to draw straight lines going east west on it isn't the way to use it. You can actually
Although the
calculate go ahead.
although the central angle distance calculator is eerily similar to how Gleason intended you to use the Gleason's map as a longitude time calculator, where it would do a similar calculation to preserve the distance. So I think the central angle equivalent is like an analog of that. I think it's really cool.
Yeah, I was gonna implement Gleason's exact method, and then I was like, oh, this actually is pretty much
Now
the
this is
same
cooler. Yeah.
thing. Yeah, so in any case, we can see here that we have two flight routes, Santiago to Sydney, New York to the Persian Gulf. They are a central angle distance of 101.98 degrees. Same situation over here. So they're the same length. They visually look different, but when you use central angle theorem or use the longitude timing calculator the way that it's supposed to, you don't get crazy absurd distances that wouldn't work and all that. It's a symmetrical coordinate system. If you calculate distances within it and, and you get the wrong value, the issue is it's a skill issue. It's not a map issue. So these flight routes both take off at the same time. They both land at the same time. Therefore, they're traveling the same speed. We have it. I started with angular units for speed because I didn't want to do kilometers or associate any Earth radius stuff hard to it yet. So anyway, it has the angular amount per hour, and then it also converts that into lees and boos, and then we convert it into kilometers per hour from the lees and boos, so that it's like a relatable thing, so you can understand it or whatever. But yeah, these two finish their flight path at the same time, and they visually look like they're different distances. Now, that's just an aspect of the projection. But Alan, it's a different distance. But when we look at it with a another projection, same distance in the north, same distance in the south. It's just an aspect of the projection, the way that the lines look in the north and in the south. As you get further in the south in the Gleasons, the projection gets more skewed, but it doesn't actually change what the distance value is between places. So, like the fact that Australia looks like a different distance isn't physically meaningful to the projection because the longitude and latitude lines that traverse it still represent the same distance they would in the north. And you can verify that through central angle theorem, which is, I think, the most straightforward way to do it. Because if the angle in the north is the south, then it's the same in the, or if the angle in the north is the same as the angle in the south, then it's not going to be a different distance. That should be pretty straightforward. So we have some different flight routes here that were proposed. Oops, it's visually skewing out here to the tripole lines. But you can see here when the flight route is just the same distance, it's just the way that the line looks on the projection is what's different. So it's the same amount of distance in kilometers or whatever. Now we have some analemmas. So we can go to the North 45, play out an analemma. We'll speed it up here.
I just
Oh yeah, when
recently
you track,
learned that term. Could you define
yeah,
analemma? I think that's an important one.
yeah. So the analemma is if you take a snapshot of the sun, I think it's like, was it 31 days apart every month? Um, you'll get this change in elevation snapshot that makes this pattern. And relative to the latitude, you'll either see the pattern have like a really
Like
wide
a
and long
figure eight.
shape to it. And yeah, figure eight. And so that's made through taking those snapshots throughout the year. Yeah. So we'll play that
Yeah,
out
same
so you can see
spot,
what that
whether
looks
your Earth
like.
is flat or globy. If you do that every
Yep.
day.
No, it doesn't work on a flat Earth.
Well,
If
this
you
is
have
a
an
this is a
arc of,
discussion of cameras. Are we against
Let's
cameras?
let's just hold up until the
yeah,
presentation's over with.
yeah. If you perceive the heavens in a vault like this, then then the way you perceive it wouldn't be mutually exclusive to a globe. And for
Yeah,
those
the whole point
curious
is
minds,
the observations are
yeah,
equivalent. That's what this shows. That's what we argue. That's what we say. That's what we stand on. That's what the model shows. That's what we modeled. That's what we're looking at. They're all equivalent, all based on the same hemisphere of
Somebody
observation.
mute this moron.
He's one of the ones that made it, dude. That was
Yeah.
Shane.
or my mic was muted. Thank you, Shane. Here's 300 years of citations going over how the heavens are perceived in a vault, a flattened vault, or a curved dome, or a flattened curved dome, like all these different ways to describe how we perceive the sky as a flattened dome or a flattened vault and whatnot. So you guys can go through these and check those out. The purpose of this, though, like Shane was saying, is to show that the optical equivalence between this isn't mutually exclusive, and using an internally consistent system to define change distance on the ground as a function of angular change of Polaris in the sky isn't mutually exclusive either. This system was done before the Europeans were formalized it, because they had to repropose it to the Chinese, who were already, doing this. So it's not an issue of like, uh, you stole it from me, I stole it from you, or whatever. It appears that every civilization that was geocentric flat earthers, and especially the ones that got into navigation, they all were using this exact same system. And instead of sailing to a true position of a star, a position that you never see, they would just sail in the direction of said star, and then reference, where it was longitudinal wise in their coordinate system, from eclipse timings and whatnot. So none of this is so in other words, celestial navigation isn't mutually exclusive to a globe or any particular shape, because this coordinate system that defines this is bound to that fictitious observer to linearize everything, to make those fictitious points relative to keep this system perfectly symmetrical. And if you didn't account for the fictitious position and you were trying to do it off just the apparent positions, what I learned from Celtheo and the refraction stuff is that there's about 20 to 30 arc minutes of refraction that ends up being invoked for like the timing difference of when it should be occluded by Earth going over the equator, essentially. So then like you're totally blocked by that curvature in between you and the star. The timing difference between that would equate to, 20 arc minutes is 20 nautical miles. So it would be about plus or minus 20 or 30 kilometers on the tropics and the position of the equator, et cetera, if you don't like force that symmetry with the true position. Then, and then there's also each hemisphere has their own respective North Pole, what do you call it? Like radius value, where it's the normal radius value plus 20 kilometers. And they have that on the North and South Pole. So I thought that was pretty interesting that, if you were to try and base it off of the same thing, like the difference of that would lead to the same kind of, would be the same kind of offset. So then we have, let's see, we can do 24-hour sun. So this was a big part of why I made this too, to have the visualization for it and everything and understand what's going on with that. So let's see here. Go to, hang on, I'm going to reload it so that that grid is removed. Sorry about that. Okay, so if we go to the demo now, and we look at it in third person, let me turn on vectors. Vectors. Action vector. Why is it not showing?
What are you looking for?
Dang nabbit. Dang nabbit. There's supposed to be a straight line showing the direction that the observer is facing when the vector thing
Isn't
is
that
on.
part
But it's
of
not.
azimuth?
No, it works with azimuth, but it's not directly.
Is that the dome caustic
Shoot.
at the bottom?
Oh, did I turn off the star? Hold on a second. I think I turned off there we go. I turned off optical volt. That's what the issue was. Okay, here we go. So we go back to what's north. Here we go. We go back to the south. We pause. We look here. We see in this projection that the observer is facing, out here into space where no light rays actually converge. Doesn't make any sense. And then one of the things that we did do to try and see if like a coffee cup caustic effect would work, we came up with dome caustic here. And so you can't see the ray trace stuff because I have it disabled because it was too much to visually see. But you can see here what happens is the rays would converge on the opposite side of what the observer sees. So then you would have to say that that in addition to this second sun that would appear in your field of, or in your vision opposite of which way you're looking, that then there would be an anti-corpuscular relationship that brings it out to the other side, and that doesn't seems unnecessary. And then when you play it out, it also that projected sun never actually goes in the correct direction to match that. So it never, so that's the coffee cup caustic doesn't seem like it would be a tenable solution to that. So that one was ruled out. But then when you look at, but another thing to kind of consider though is that, so we're looking at the direction of the sun, or we're looking at the direction the observer is facing as the sun does its transit there. And then we see what it looks like on the globe. Okay, bottom of the globe, so like doesn't require any anti-crepuscular, stuff like that. Makes sense perfectly. But you got to remember the way that the observer is facing from the God's eye view is something that nobody sees. And when we're looking at the way that they would be facing in the projection, that's an aspect of the God's eye view perspective. The direction that the observer is facing is always facing towards the sun in that scenario. So if there was another scenario where, um, let's say Antarctica was its own continent and the ice wall that we all conceive of is separate from the projection stretched out from the AE map, and this was an actual place, well, then you would have the observer looking south as the sun, go or as the sun goes around them, and it doesn't look like they're looking off into space or whatever. And the directions again are all lined up based off of the type of projection that it's using. So my argument would be that we don't live on a map projection. This conceptual layout of how the continents looks is probably what it looks like. But in terms of merging two hemispheres of the sky together to have a mutually exclusive ball and whatnot, I don't think that that's the case in how it's actually works. I think that's just a way to merge the conceptual uh, hemispheres together of what an observer would see in their respective hemis, and then linking it together. So, Shane, was there anything that you wanted to cover that I missed?
No, I think you did a good job. But the basic principle of the unit sphere, right? Unitless dimensions, no globe radius, no circumference, no distance to the sun, no AU, no
What
astronomical,
is
like
unitless?
no globe constants whatsoever. Literally takes angular inputs, right, with right ascension and declination, all observer based. So the whole point of when we argue that it's all ratios of each other, when like we use Kepler instead of Newton, and we argue about stellar aberration with Bradley, with the ratio and the radius dropping out, all being ratios. This, I think, demonstrates that more than anything, because if you remove all that, everything works exactly the same. So I think that's a really good demonstration of what we've been arguing with the conceptual two-sphere model at the backbone between everything. When you put it in globe mode, like the two-sphere model of like the conceptual terrestrial sphere and the celestial sphere, like that's the same principle as the flat Earth with the star disk floating around it. Like that's just this is exactly the same same principle as the dual pole. You have something being observed to the person, and you have something that's rotating above you. And I think this is the closest that we've been to emulating how we think it truly looks.
Nice. Let's see here. I did add something to. I remember when we were doing Celtheo every week, there was some contention on what the observer predicts in terms of earlier timing for the geometric alignment. So I think this adds a really good demonstration of that as well. So what we can do here is we can clear all, and we can go down to Celtheo stars, pick one, go show. And what I want to do here, go to observer, go to 3800 thereabouts. I think 104, that's probably correct. That should be, yeah, right about there. Okay, cool. And so let's see. So we're in GE mode. We go to the center here. We see what the observer sees. There's 93 Aquarii. It's currently at 23 elevation. I'm in the demo right now. 3 Aquarii. There we go. Well, you know what? We can just go to the exact time. Is- One second, just had this. Is it daytime?
Oh, we should show eclipses too, if that works.
Oh yeah, it does. One second. Why isn't this?
You guys have examples of the vernal equinox?
Yes, we do. Why isn't that rendering?
Do we have? Did you make a basic demo for like seasons? I don't think so. I don't think we have a seasons demo. I think
No.
we have the north-south demo, but not the. So maybe equinox and seasons is a demo we can make still.
Why is it not rendering though? One second.
Maybe just try opening the app again fresh on another tab.
Yeah. Good call. All right, so pause and then go to globe, go center of the globe. Then see what the observer sees. Yeah, we could just do it like this. Okay. So two. So, one second. Okay.
And I think you're safe. That looks nothing like Nicki Minaj.
It's not Nicki Minaj. Okay, so dang it. All right, we'll just do Venus, I guess. The star things aren't doing it correctly. Okay, so
What are you trying to show
so-
again?
Well, I was going to show the true position and apparent position difference from the center, but I couldn't get the stars to change position.
Oh,
there.
that circle when you're adding the cell refraction, because that's on.
Yeah.
Did you talk about that? I see that on now.
Yeah, I'm trying to show that now. So if we go to the old ball center here. Okay. So celestial sphere standing, on the ball or whatever, and then consulting what the fictitious observer would see. We have this. So we see that the true position is down here. It's this. It's represented by the this white circle intersects with the true position, and the radius of that circle is the angular difference of the refraction amount as it gets closer to the horizon or gets higher in elevation. So this circle will scale proportional. So the center of it is the apparent position that you see. This true position down here that's marked is the position that you don't see, and that's the geometric difference in the timing that we reference. So when we talk about why the globe predicts an earlier position geometrically, it's because their geometric position is always references the fictitious observer at the center. So it's always a lower elevation than what the observer on the surface would see. It's pretty straightforward once you see it like that. Oops, let me go back real quick. Back to the center. And then so we'll play out Venus. Oops. It's not tracking. So what if we watched it rise instead? And we'll just pick a star. Oops. So anyway, it should be. It's because I was hella zoomed in. Yeah, the tracking doesn't work as good when you're super zoomed in, but yeah, you can see the scaling different, like how the difference in separation between them two. So pretty straightforward. So let's see here. What did you want to see? Equinoxes, someone said?
Yeah, do you have that?
Yes, I do.
Oh,
Yeah, that'd be cool.
Yeah. So let's see here.
from the God mode, right? They all work in God mode, right?
They all work in every mode.
Yeah, I think they all work in your native, whatever you're looking at. It continues that
You passed it?
successfully.
Oh, there it is. Yeah. Got it. Okay. So let me turn refraction off so we're not distracted. And then we could turn on the vault grid, optical vault grid, so you can kind of see optical vault grid. You see optical vault grid anywhere, lads? Oh, right here down at the bottom. Okay. And then we'll turn on the little azimuth ring. So you can see here. Oops. You can see here we're looking. Well, let's go to the equator. Let's go directly there. Okay. So now play out the demo. Hang on, it's still. All right, we're going to do the old reload and then try that again. It's not it's not tracking the sun automatically now. There we go. So it's just playing the demo and then it's rewinding. It's not like playing it to set or whatever, but see if it.
Where is you? Are you at the equator for that?
Yeah. It should play it to set and rise. Yeah, there we go. It played it almost all the way. So yeah, there you
Nice.
go. You can see it.
One of the cooler things
West.
is if you change like your model during this, like if you look there in the globe mode or the flat mode or the dual pull mode while the demo's running, the first person mode is identical on all of them because that's what we argue. It's all based on a hemisphere of observability. Everyone only ever sees half the sky. I don't understand why people have such trouble with this concept. Right, so that's what builds this model. That's what the globe is built on. That's what builds the celestial sphere model. That's what builds the two-sphere model. It's what all models are built on, the actual observable hemisphere that anyone sees everywhere.
Well, yeah, but you can have multiple people and compare what they see.
Yeah, but then you're creating like this God's eye view where everything has to converge and all that, and none of that's necessary to use this system to navigate.
So this system actually is pragmatic in the sense that just based off of ratio simply, you can derive those, come up with patterns to make predictions for the future. And
Yeah,
they're
based
simply
on-
from each observer. Yeah.
Yeah, dude. Epicycles does it from way back when for 2,000 years with remarkable accuracy still.
So this looks like by far the greatest thing I've ever seen anybody in FE do. It's a useful tool. It's got multiple models to test. It's covers a wide range of stars, sun. So this is very good in my opinion.
Who
You guys
showed the
did a great job.
eclipses? Thank you, sir.
Oh yeah. Oh yeah, we'll run some eclipses. Yeah, thank you for the compliment. I wanted to make a nice tool that everyone can use and customize. You can go through different settings here. You can turn on Vault to the Heavens and have like a firmament. You could move the star field, adjust it in or out of the firmament. Like, how people are always like, are the stars in the firmament? Are they out? It doesn't matter. All anyone ever sees is what's in
Doesn't
this.
matter.
So, but for visual aesthetics, You can adjust and slide everything to your liking and make your own, however you want to conceptualize it. If this helps you visualize it, that's what this is for. What was I about to show? Something important?
No, Sheila, just
Eclipses.
real quick. It's not
Yeah,
your contention that when you go to the flat mode and it shows like the view that you're looking at, it's not your contention that that's actually the layout and relative sizes on a of the flat Earth in
correct.
actuality, right? It's just a visualization. You're not claiming that that's what the flat Earth actually looks like in terms of if you had like an overhead view.
No, it would probably be closer into like proportions like this or whatever, but like in terms of layout, but in terms of like where everything's positioned exactly and the scaling and all that, that's just conceptual scaling to the coordinate system, but it's probably laid out very similar to something like this.
So I
Like if you
missed
had a
it like
top-down
earlier
view.
on. Were you explaining earlier on? I must have missed it. Like how you get the 24-hour sun in Antarctica.
So I was explaining that in terms of the direction that you're facing with the God's eye view perspective. If you were to say that, like, we live on this model 1-to-1, and what we see in terms of like true positions going over us, referencing positions that people don't see from their perspective, you would be from this from this God's eye view here, you would be facing the wrong direction. And that, if you were to look at it, so I skip to the 24-hour sun real quick here so you can see, and then we'll change perspectives here. You can see the observer here is looking out into space where there's nothing. But my argument is that this is, oops, where's the, why isn't it oh, because it's not tracking. Anyway, you can see here she's looking out into space, but then when you go to different projections, that direction all changes, but the angle or the azimuth remains the same, but just how you conceptualize it is different. So I would say that if Antarctica isn't what we thought it was in terms of that being the ice ring that gets converted when you do the AE projection, and Antarctica was its own continent or something, and the ice ring was like a separate feature, then when you look at it through different projections, you would see that the observer is facing in a direction where where the sun isn't, where it doesn't look retarded. So I think it's just an aspect of the projection and trying to merge the two together. And I think that was a mistake to argue through rhetoric and all that, because all anyone ever actually sees from where they're standing is inside of, this vault of how you perceive the sky.
Yeah. And so, I mean, having been in the comments so far and seeing some of the responses, the two biggest objections so far I've seen is that we use spherical trig, like we use a whole bunch of spherical trig to represent where things are, right? Based on the observable hemisphere. We use the same hemisphere. Like the difference between hemispherical trig and spherical trig is a negative z value when things go below. So it's literally identical. So the first objection is because we use spherical trig, or we look up and we reference things in the hemisphere that we observe them, then that's the globe. And that's been the biggest objection so far, which I found quite laughable and hoping that you guys can do better. And the second one, of course, is, hey, Australia is not that size. Flurfs, go get a map. That's been the only objection to the model as I've seen it. And again, it's the map is not the model. It's an observer-based sky model. It shows every observation without any globe constants. The whole point is, right, you guys think the sky is curved because of Earth curvature, and we removed Earth curvature and everything about the Earth curvature, and the sky looks the same way. So it can't possibly be because of Earth curve. We removed all that, and we can show it looks exactly the same. So your contention that everything you see is because of Earth curvature is under contention.
So can I ask a question real quick?
We want to have constructive conversations, please.
You have a question. If we are in Antarctica for the sake of argument, I think you already broached on the topic, but we're in Antarctica and we see the sun due south. Is it your suggestion that we're actually looking back across the Earth and not looking into space? Is that what you were saying?
Yeah, I'm saying that the direction that you're facing from the God's eye view that we're looking at isn't necessarily the direction that you would be facing in reality, because directions get corrected to the fixed positions of where the stars and stuff should be for latitude and longitude. So if it's referenced within that coordinate system, you know, under different projections, it's going to look, you know, all fucked up or like you're looking in different directions and stuff. So, you know, that's my argument that the directions are being defined by the coordinate system.
So are we actually looking north to look south? I'm just trying to understand what you're showing.
Yeah, possibly.
Like not just
yeah, like I said, if Antarctica was its own continent down here like that, then you know, it would work like that.
Well, then in that projection, then all three would be looking in the same technical direction, right? That's why that one works. So there's one. If you put on true position, the true position is the same azimuth for everyone, so it makes sense.
Yeah.
This is the value in this model is one can look at all these variables and stuff and actually ponder these things. So this tool is going to bring value the more you use it.
Yes, sir. That's that was my exact thoughts, and that's how it was when I was, you know, I learned a lot building, you know, going through building this and how everything works on the inside. It was fascinating to see, you know, everything is literally just ratios of a unit sphere and then bound to time to a fictitious observer, and none of that is mutually exclusive. So hopefully that illustrates the
And I still haven't seen an eclipse, dude. This is crazy.
Oh, I'm sorry, dude. I'm so sorry. I'm so sorry. I'm so sorry.
I'd like to see the flight paths too after.
So we can watch eclipses play out in.
Oops. Oh, look at that! Oh yeah.
So
there we go.
So there's different ways you guys can do eclipses. You can go to the demos here, and then there's different eclipses that you could play from different time periods or whatever. Or you can hit this button here and cycle through different ones, and it'll play the next one that's coming up in the demo in real time. So we have a moon phase cycle thing here. You can see when the next lunar and solars are coming up. But we also show the shadow projected for the umbra and penumbra using a bunch of Baselian polynomial stuff that I don't fully understand, but Shane could talk to you more about that stuff. But basically, it's just plotting it, you know, over the coordinate system. So yeah, you can see what the shadows and stuff look like. Let me turn on the sun and
am I right to assume that eclipses work in all so we can watch a dual pole eclipse real quick with no qualms, right? You can just switch it up and
yeah, absolutely. Let me try and find the sun in the sky here. Sun. Oh, there we go. So I think that eclipse just finished, actually. Yeah.
I think you have to be in the shadow to put yourself in first person to see the eclipse. You have to be on that line somewhere in the shadow.
Well, not way west and a little south.
Yeah, I was outside of it.
Can I ask one of the mods to unmute Robert Silverman? He had a question for you guys.
No, this ain't no.
You can ask it for him.
Okay. Well, his question is, where's the geographic South Pole?
Ooh, good question. So back when the Chinese mapped out the South, what they did is they used a conceptual South Pole by using the two stars that lead the Southern Cross, the something crux or something. So that points in the direction of Sigma Octantis, which they would say is their southern pole star. And so from that's where they referenced a geographic South Pole or whatever. It was always calculated in the sky. They never did anything on the ground there. The only relationship that that was like necessary for them was to map the relationship to the change in canopus over distance to make it the same as like Polaris. So they didn't even use like Sigma Octantis or whatever that, you know, I guess they couldn't even have seen it because it's not very bright or whatever. But yeah, they didn't even use that. They used canopus to map it out symmetrically. So.
The problem with that is that in reality, it takes almost the same time to go from South America, South Africa, and Australia to the South Pole. How can that happen on the flat?
That's just a map objection. Like, I mean,
Yeah,
I don't
yeah.
even
So
know.
when the coordinate system gets projected, it visually looks like it's a different distance and different length. But what we went over earlier through central angle theorem is we showed that an arc in the south is the same length as an arc in the north, irrespective of the projection. So it
Just do
just looks
flight
that
path
way
central angles
essentially.
again. Yeah.
That means that the Earth is a globe. Thank you very much.
No, it means that it's referencing a symmetrical coordinate system that's bound together in time with a fictitious observer. That's the whole point of showing this.
All right, that's the conceptual two-sphere model in action. There you go. Derived from angles to the stars, one for one modeling the terrestrial to the celestial to get the conceptual model.
Yeah, in any case, was there another demo you wanted to see, Shane?
Can I see the equal arc flight paths?
Yeah, that one.
Equal arc flight paths. This
There
one?
you go.
Yep.
Boom. I love this.
Yep.
So distance is basically displayed by arc length, right? Instead of
Yeah,
meters.
so I added the meter and Lee conversion after I added the units, but yeah, you can see the arc distance or the central angle difference between the two is 101.98, 101.97. That's just where I paused it or whatever. They're the same distance.
Can you do the square thing? Can you do this? Can you do the square thing real quick, Alan?
Oh, I'm sorry. What was this? What was? Can you make a square on the map and tell me the distance? Oh, so that'll be a separate feature because I misunderstood what you said. I thought it was I thought you meant I thought you meant add like a Mercator projection where it's a square and then calculate through that to do what you're
No,
wanting
you
to
said we
do. I
could
could
get.
do that.
You said we could
Yeah.
get the distances on this thing. So, like, can you make a? You can't make a square.
Yeah.
Only 2
Well,
points.
I can only do 2 points. I'd have to add another one to do two more and then do like the area of it and stuff like that. I could,
Can you
or I'll add
can you
that.
show the while you have this thing up on the flight paths? Can you show what the flat Earth flight path is from Sydney to Santiago?
Yeah. So quick thing to understand, like especially in terms of terminology, there's no flat earth map, there's no flat earth distance per se, right? These are all referencing the same coordinate system under different projections. So this isn't any more of a flat earth map than it is a globe earth map. These coordinates, like these lines that define the meridians, are a spherical coordinate system under different projections, so they
Oh,
all
I see. They're
represent the
just
same thing.
got it.
Yeah.
These are just projections of the globe Earth.
Well, the
Projections of the
projections of a
celestial
coordinate
sphere.
system
Very
that people
cool.
say is the globe Earth that they can't separate the two from. Yes.
Yeah, that people can't
Shane, you
separate
Can
the
we?
abstract
you
spherical
Is
agree?
it
coordinates.
possible for us to play? Is this on a website we could play with?
Yeah.
Oh, absolutely, absolutely. This is
All
on
right.
my GitHub. I'll link it here, and you guys can.
We're gonna
And then,
play
like,
with
if
it.
you guys think of
I
any,
bet you.
if you guys think of any features or come across any glaring bugs other than what I showed earlier that I had to deal with, let me know, and I will get those fixed. And it should work on phones and whatnot. Like if you're in your phone browser, it should work pretty good. And should you feel so inclined, you can, while you have the thing open in your phone browser, you can open up your phone settings and then go to what is it, add to home, and then it'll ask you if you want to install it as an app, and it'll install it as an Android app. There's no tracking or data, or you don't have to sign up for it or anything like that. It's all just runs self-contained with this stuff here. So that's basically it. If you want to use it and check it out, it's available here on the GitHub, and Shane put the link there. And I update it every so often. I just reached a comfortable point in it where I don't feel like there's anything much more to add to it. But if you guys think of cool stuff, just let me know and I will add it.
Well, I think it's pretty cool that you don't talk
The
about
ground in this is flat, though, right?
Yeah. So the coordinate system is spherical, though, obviously. But when you're looking at this projection, like the ground, the ground would be flat, and we're using the arcs in the sky to navigate. So yeah, it would be flat in this, but we're using a spherical coordinate system. In this one, spherical coordinate system and the ground would be curved in this one because the celestial and terrestrial sphere are 1-to-1. In this one, we're using the same projection of two hemispheres split together, and we're seeing it as like a God's eye view split of the same thing. So, this one would also be flat, but seeing it all as like a whole is kind of misleading because all an observer would see is wherever their hemisphere of vision is at. So,
Yeah, dude, one of the takeaways I
yeah.
had from like running through all this was the God mode is misleading. Or like no one ever sees the God mode. So to try to envision how everyone's observation looks from God mode was kind of a weird off-putting thing. And then to compare like directions, like the directions the star moves, for example, has to go opposite to what you prospectively would observe because the sky is in between you, so it goes the other way from when you're looking down on the whole world from God mode. So it looked off-putting like it was going the wrong direction. We had to compare it with stellarium to make sure it was showing the correct motion. But I think the thing that I took away from that is God mode is weird. It's weird to envision a God mode view of the Earth, I think.
Almost like it's forbidden.
Or is it even possible to be able to see the whole thing?
Yeah, kind of like that.
You're forgetting we have the internet, so you can be with someone in the north looking at the sky at the same time.
Hey,
Yeah,
Alan,
so we're not
I wanted to ask
forgetting
a
the
question.
internet. It's the scale in which they would say that everything converges to that makes it fictitious and made up because nobody sees that. What your friend would be referencing
Yeah.
that you call or talk to on the internet would be seeing what he sees in his respective dome, and then you guys would compare. So, what was the next question?
Why do you
I had
call
a question,
on
yeah.
Hold on,
GLOC?
Max, hold on.
Oh, yeah, let
Jesse,
Jesse go.
you had a question?
So yeah, in the first few minutes of the presentation, you were speaking about how we pretend the observer is actually in the center of the projection. And that was a great breakdown. I was trying to say this yesterday, and you did it better than me. But I wanted to see that projection again. You know, the stars are overlaid actually on like, because we pretend we're in the center of the Earth, right?
Yeah, at all times they do that. Yeah.
That's the one. Yeah, this is what I wanted. Yeah, that's cool.
Yeah,
Thank
this
you.
is how they merged the two spheres together for the celestial and the terrestrial. All this was done. All they do here is they treat the stars as if they have like no refraction angularly, and then they just add 15 degrees per hour to them, and that makes the whole system. So they're always comparing to where the star isn't when they see it visually, and then per every 10 degrees of angular elevation, there's amount of refraction that's like associated to that amount that they subtract out to compare to this position.
The terminology is misleading. They call it the true position. It should be the fictitious position because it's only ever observed and determined by this fictitious observer at the center that nobody can ever confirm. It's so weird they got us. So it's the fictitious position.
I thought I heard you
marketing.
mention also that it actually changes the angle rather than pretending you're in the center of the Earth, that the angle changes when you actually treat yourself like you're on the surface. And then I thought you pulled up a projection like that. Or not?
So the angle doesn't change, but the way that you're viewing it from the God's eye perspective, you see the observer looking off in different directions that wouldn't make sense on the projection.
Thank you.
You put the stars in default mode so that we can see like all the, I think instead of dynamic, I think star field option. Yeah, I
You
find
want to see it like that?
Yeah.
Yeah, there it is. Yep.
Yeah.
Oh,
Yeah,
there
because
it
the
is. Yeah.
distance that the celestial sphere. Yeah,
Just
I wonder if
add
that
light-
would
Yes,
affect the
sir.
angle.
I was just gonna say, just add light years to that.
Yeah.
This,
You know?
this
So real quick, because we actually could do that, Geo, and it wouldn't be an issue at all. So because we have the same dimensions that they use for the globe to determine like the astronomical unit when they took an
ratio
alignment of
of the
Venus
same.
at a certain, they took an alignment of Venus at a certain time when it would make like a straight line to us for the baseline of a triangle, and then they converged those to the sun using the center of Earth as the starting point of the side of the triangle. And so the astronomical unit is a ratio of this radius itself. So for the globe lads, they would use 6,371 kilometers. And for us, we would just use whatever this is in lees for the radius. So I think that's 26,914 lees. And so anyway, we could make this a ratio of an astronomical Lee, and then we could have our own distances to the sun for the full convert. Like, but none of that's even physically meaningful or whatever. But that could all be done. That's all it is. It's just a central angle ratio to the sun, assuming that the Venus is perfectly aligned and has a similar radius.
I have a question from a friend of mine. He doesn't have a mic in chat from Garrus. He wants to know what causes the dark spots on Earth.
Ooh, good
like
question.
in your model.
Let me show you this. So, like I said earlier, we do not have the, that God's eye perspective view. So one of the things that I'll put forward right now is, this is just hypothetically speaking, right? This isn't for sure. But what we can show is perhaps a giant tree in the center, Gio. What are your thoughts on that?
Oh my God.
Yeah, dude, I saw that. I put it out there.
Shout out to PC. Shout out to PC.
I prefer the toroidal tree, which is the toroidal vortex and the tree, and then somehow I can say that they're entwined.
Yeah. Honestly,
it doesn't do it.
Yeah, those are both
honestly,
awesome.
honestly, I make no dynamic claims for how light distribution works in terms of why this looks this way, in terms of why it looks better
Like
on
the
the globe
geometry
because
and
you
stuff.
can because you can break it off. Yeah, I have no idea what goes on in the sky. Like this isn't the shadow distribution, but this is what it looks like, on that projection or whatever. But in terms of like what
Yeah.
produces this per se, I have no idea.
And can
I
I
have
also
two
be clear? Because
questions.
okay,
Finish up
can I ask
if
real
you
quick?
want to.
All right. Is this a dual pole or a single pole map?
All of them. He's got all of it. Single, dual,
Yeah.
globe.
Tripole, I think,
So
is in there now.
Yeah. So it's all the same coordinate system. It's just aspects of how it's projected. So the South Pole on this projection is stretched out around the ring or the rim here. And then in this projection, it's just at the bottom, on the other side of the bisecting meridian here. So if you think about the equator point here being the symmetrical midpoint, instead of looking at the bottom stretched out, you're looking at it converge. And then on this one, you're looking at like what would be a slice of each hemisphere and then put opposite to one another so that you could see like the two hemispheres merge together. So they're all the same projection. They're just basically offsetting the symmetry of it to different points. And then we have the God's eye view of it that we look at.
Okay, thank you. I appreciate it.
Yeah.
I have two quick questions. Why does it call to VSOP 87, which is a globe ephemeridis? And when you just log in, when you just go into the thing, I can see a bunch of green dots moving around very fast. Are those satellites? And if so, why are they hitting the ground? Thank you.
They're satellites and they're hitting the ground because that's where you would perceive them hitting. If you click on the true position, you can see that they're going in the same pattern but above us and not going below us. That's just how you would see it in your dome of vision. And
but on
let's
the
see here.
ephemeris
And
claim,
then real quick on the ephemeris claim. When you load in, the only ephemeris that loads is Fred Espernak's geocentric ephemeris, which is taken from reducing the DE 4051 to its geocentric stuff. And then we didn't even pull any distances or any mutually exclusive heliocentric claim stuff, literally just angles and time for the positions. And then so when this loads in, this is all that it's referencing for the planets and whatnot. So there's a ephemeris comparison mode. So we can see here with just this one loaded, it's not comparing it to anything, but we can enter comparison mode, which will load a geocentric ephemeris, which is just it's a Python module of a heliocentric ephemeris. It starts with the heliocentric frame and then it subtracts that out and then it goes to the geocentric. So all I did was just remove that subtraction transformation so that it just starts with the geocentric one. So that's all that is. And then there's the Ptolemy one, which is Ptolemy's original ephemeris stuff. And then there's the Fred Espernak one. That's this one right here. And then there's the VSOP one, which is the heliocentric one. But you can see here that the difference between the geocentric and the heliocentric one is 9 arc seconds. So there's no real perceptible difference between them, and they're not all loaded together. So
And on top of that, we have this other separate model totally built by itself called Shane's Model 2.0 that uses no VSOP, no heliocentric, no even DE. It actually runs entirely on Ptolemy's model, and it's the GFY version. So it's just for an sake of argument, because we found people were not determined enough to look in the source code to verify what Alan just said, and that the function only references the heliocentric VSOP for comparison when the ephemeris option is turned on or when you purposely select it. So no one was willing to verify that. So here's a standalone model that does the same thing, and here's the separate GitHub for that.
Wow, it's like you weren't paying attention.
Didn't even watch.
It's all good.
Was that a lunar
It's
that
a
y'all
lot to
showed?
take in. What's that?
Yeah, bro. I had it the other day. I was sharing it on the live stream, and I put it on the dual pole mode, and then I think I went into, you can do the 24-hour sun, the 24-hour sun, and the 24-hour moon demo. That one is really cool. It's the 24-hour sun and the 24-hour moon, and then it basically showed them going through their whole circuits from the north to the south throughout their cycles. It was like one of the best animations I've ever seen of the sun and moon motion above a dual pole that I've ever seen.
Ooh, where do I click on to play that one? I haven't seen that.
There's the 24-hour moon and the 24-hour sun. And there's the one that's both. If you scroll down a little bit, I think it's kind of near the middle of that hole.
Oh, you were almost there.
Oh, the demos are searchable. I forgot about that.
Because I had it playing. I had it playing through time, so it would do like the 24-hour sun in the north for 6 months, and then it transitioned to the 24-hour sun in the south for 6 months, and then the moon was doing it once a month. Like it was all working.
Oh, nice. That's good to hear. Yeah, I don't know which. So was it?
You should be able to right click that and open that list. You should be able to right click that entry and open that part of the list. You know what I mean? Browse folder kind of function.
Really?
Yeah, that would be. Yeah, I will.
So get Claude on it real soon, bro.
I will, because that's super annoying to not be able to go right to it like that. Yeah, I don't know which one.
Set the calendar year to the winter solstice, and then do the 24-hour moon, and then it'll probably do it.
There's also the sun and moon analimas that are combined, I think, as well. I'd have to open it back up to see which one it was, but yeah.
Oh, that's a good one. I like that one. Did you do the Sonotic one? That one looks sick.
So there is the 24-hour moon. Was the one I was thinking of the sun and moon analemma versus the sun and moon 24-hour, and the moon and sun are, the moon and sun 24s are separate, like they're their own things, right?
Yeah,
they're their own. Sun and moon analemma. That might have been it. Yeah, instead of the sun and moon, both 24-hour at the same time. But there is 24-hour moon and 24-hour sun. That's cool. You put the moon in there.
It's in March. Can you put it in December, like 25th or something?
Yeah, give me 1 second. Playing out a demo.
That is awesome to watch, actually. I didn't even know that you can do them both at once. The moon's a little bit weird, but it's accurate.
Oh, look, there was an eclipse in between there. It looked like.
Yeah, I saw that.
Are they changing speeds like when they whip around? Like, are they speeding up?
So it visually, so in addition to that, though, it looks like it's visually doing that faster, the same way that it did for the flight routes when they're extended out. But it's actually still traveling at its constant speed. It just has to do that because it's traveling on the most skewed part of the projection, or like the most unskewed part of it. So like this, when it's on the outer rim here, it's like the longest part of it, but it's not any different than what it would normally be. You know what I mean? So like the whipping is kind of like a visual scale skew. It's not necessarily like, oh, it has to then speed. You know what I mean? It's just how it looks for the thing.
I think what I hear you saying is that it's a projection, so this is like not really. It's not really what you think it is in reality. It's like one part of it or something.
In terms of watching it visually change speed to complete the circuit in the amount of time required, that's just an aspect of like what it looks like for like the visual length change, but the time difference is still proportional. That's why it has to visually speed up. It's not like a real aspect of it actually speeding up. It just looks that way to complete it in the same time that it would always do it in under another projection.
You would never see it like this, though. You're not seeing it ever like this. You're seeing it from the
Right.
surface in
Right.
your own hemispheric dome. Yeah, so
That's
you
why
would
God
never see this view.
God mode
So-
is weird, man.
Well, of these four, like of the four basic ones here, wouldn't it still be like the case though that one of them, like they can't all be true, even though I hear what you're saying about the coordinates, but they are different in certain ways too. So wouldn't it also be exclusive that, like, let's say it is one of these, or even if it's like another one, like some other entire, whatever it may be, there is something that is a true one though, right? That if we mapped out on the ground, we could make at least a map on like a table. Like I think the militaries must already have, the best maps. So I mean, they've already done it, but I mean, it would be one other than the other, is what I'm saying. Like there is something that's exclusive, right, amongst these?
No, they're all built off of the same premise, and then it's just the same coordinates under different projections.
So the same
there's
observable
difference.
hemisphere.
Yeah, you wouldn't.
with
So if
the-
you were on the ground making observations here in this mode, watching the sun and stuff, if we transform to another projection, it would still look oops. It's not on that one. It would, and it didn't carry over. Okay.
Well, do you think the
it'll just
land is
reset,
laid
but-
out? Do you think the land is laid out in like one true way? That is like the one, like an actual, sort of like if you had
Yeah,
like,
I think it. Yeah, I think
you
it
know,
probably
like-
looks something like this, and then we're just using the stars to traverse over top.
so you think this is the one
But
that of these four is the closest to what the truth is, you're saying?
Yeah, my only thing now though is like after seeing all this and how it works is like I'm kind of thinking Antarctica might be its own thing, and then the ice ring is separate than what we've conceptualized from just looking at it from the AE projection. But like honestly,
No one tell Dave that Alan just became a dual pole or whatever.
Well, it can't
No, I'm just-
possibly be that because you could never get the distances correct, especially the flight times, right? Like there'd be just no way to do it.
Oh my god.
But Jake, you got to understand, my brother, you're referencing the lines of the coordinate system, not anything different. So no matter how they look position wise, it's always going to be the same distance under any projection. Doesn't matter. So it would be the exact same. You would never know. Like one of the important aspects.
Where do you get
like a
your
real... Go ahead.
I'm just saying, where do they think distances are derived from?
Well, in modernity, they've done a good job of like trying to make it look like the meter has been removed from the coordinate system itself. So they relate a meter to a wavelength of light at a specific temperature and wavelength. But even in that, it's still a ratio of the terrestrial meridian itself, and then everything else that followed from that is all ratios of the same. So it's still conceptually the same exact thing. It's not anything different, but they've gone through some links to make it seem like these units independently correspond to the dimensions of Earth's outside of the coordinate system, so that it appears that it's not self-referential. But that ship long sailed ago, so it still is.
I think Shane, what Gio was trying to say was that ultimately, if we are on a flat Earth domain, there should be a map that you can with a proper scale where you could just apply a scale, have everything be to scale, where you could just put down a ruler, measure out your distance on the ruler, multiply it by the scale, and then get correct distances between any points on the flat Earth, right?
Well, no, that's an
That was
argument
not-
that.
Even I made, but nonetheless, go ahead.
Yeah, no, that's an argument of the 1-for-1 coordinate system. Flat Earth should have a map that's 1-for-1 without a scale, and that negates the fact that we have to use the same abstract coordinate system as the globe based on the hemisphere of observability that we have, right? So stars, everyone sees the stars. Earth is mostly water. How would you navigate over the non-land? You'd have to use the stars. We end up with the same abstract coordinate system. That's so like when you say, well, we're not mapping 1-to-1. We're still using the conceptual model. We're still using the celestial sphere mapped out from the observable hemisphere and constructing our model from that. So that wouldn't be a 1-for-1 flat distances everywhere. It would be the same abstract transfer from sphere to plane We're just arguing we're not transferring the physical globe. That's not the sphere. The lat long system, which is abstract coordinates based on the sky, that's what we're transferring. Even for you, that's not the globe. To get the globe, you have to run that through an actual ellipsoid datum, something like WGS84, which is itself another abstract spherical coordinate system. So for you, you overlay those two abstract spherical coordinate system, and that's what gives you the quote terrestrial sphere, which is the globe that you think is real and tangible.
Yeah, but we don't, I don't think that most. Yeah, sorry, go ahead.
Will have the same unit representation on the map.
Yeah,
Independent
so
of the coordinate system,
yeah.
right? You can create any arbitrary coordinate system, and it must be linear across the surface of the Earth.
Well, there's a whole transform that goes on with this guy on the ground, yeah, which you guys are both
Need the sky. You just
honing in
measure the
on.
ground.
Yeah.
Yeah.
Can I just say one thing? But
Yeah.
I was just gonna say, like, but one thing real quick, like in the South, for example, the distances between the southern continents, if we actually measured those, like for the dual pole versus like the AE Gleasons, it seems like that would be a dramatically different distance. So that's the question. Like, if one of those is true and one of those isn't true, then wouldn't that mean that one of these would be closer to reality based on even just the distances between the southern continents?
Even
'Cause
though
the
it
two,
visually looks different, though, it's the same distance that it would be in the north. So check this out. We could take a distance here. Oops.
that's so cool. You got the light pattern because that's one of the ideas of how it's working. Which actually, this matches with like the way electric fields, like that.
Why is that central angle thing not working?
Yeah, all the light patterns are technically correct. Like, I don't know why we said that we don't know what makes that. Like, sunset makes that. The argument that we don't know is that we don't know what what makes the sunset, right? Like, no, like the sun lights half the Earth. It's the same argument with everyone observes a hemisphere. Why argue for different observations for the other model? Both models make use of real observations. So just assume that we're working with a half lit Earth at all time, and that flat earthers have seen nighttime.
Alan, when you were saying that there's another ice wall, is there any evidence for it, or just
No, none at
the
all.
fact
Just
that you need it to be the case?
Nope, just purely conceptual. Just spitballing with the boys.
Shane, you agree that if the equator,
So there's no value in that. Okay.
Correct.
on the flat Earth projection here, if the equator is 25,000 miles, then then our distance from any point on the equator on the flat version to the center, which would be where the North Pole would be, that wouldn't agree with what we accept the distance on the globe Earth to be from the North Pole to the equator, right? Because
Nope,
it would be a much smaller distance on the flat Earth, right? Because then it would be 25,000 divided by pi, which is going to be, no, you don't agree?
No, you're trying to use an arc in the sky as a straight line for a radius, and that's not what the system is built on, and that's not what anyone would do.
Yeah, it's a geodesic. You can't make that a straight line radius.
Let me turn this on back real quick.
I'm not even looking at the sky at all. I'm just saying, imagine that there is no sky at all, that we're like ants that only live on one plane. I'm just saying, on the flat, the circumference, if it's 25,000 miles on the equator, is the circle path around the equator, then you would have to the center of that circle would be your distance to, essentially the North Pole, right? Which would be 25,000 divided by pi. But that's not what, people that have driven or, done like, the North American, Pan American. I'm just sorry. I'm just trying to be
so no. And the arc in the sky was so, like, in the same way that the globe would say that the radius extending out from the center to this to the surface at the circumference isn't the same distance as an arc isn't the same distance on the surface from the North Pole to the equator. It follows this geometry right here. It's represented by this arc. When we put the observer in the center with its hemisphere of vision, that arc that's made up of the radius value to the where it intersects with the circumference, and then adding a height component that's also the same height as what the radius value would be. That arc that completes the two would be the surface distance. So if you were calculating distances based off of angular position of Polaris as it changes over distance, the way that we're using this same system, the way that the Chinese did, when they're traversing out on land, they're actually referencing this arc as the change in position for ground traversed to relate to the change in Polaris. So it's exactly identical. There would be no difference.
I'm ignoring this guy completely, though. I mean, you could take
Yeah,
a motorcycle
so
from the Pan American Highway, right? And you can drive from, whatever that Black Horse or whatever in Alaska, on the Arctic Sea, and drive to the equator or right to the equator. You know what that distance is. And then
He
we
did
also
all that, dude. It's in the unit of lees. He did all that.
Yeah, I literally just answered that. It would be the exact calculated distance that the globe would predict in kilometers from the North Pole to the equator. The exact equivalent is shown here in lees. So there would
So
be
then that
there
can't
would
possibly work on a flat Earth then.
no, because it's tied to a fictitious observer to linearize the 60 nautical miles per degree. Using a fictitious observer doesn't make it mutually exclusive. It means that Earth
Well-
curvature is another hypothesis that needs to be tested in a different manner other than observing things in the sky and traversing distances.
I think these guys also need to realize when you put this on the globe, you have to put the observer at the center. I don't know if you guys are realizing that. If you put the guy on the exterior of the sphere, it also distorts everything. So there's a problem in all that whole thing.
That's what I was. That's sorry, Tora. But yeah, I wanted to see that again. That was fuck. It went away.
But
So
the
you guys are
equatorial.
It showed the dome above, celestial
Good.
sphere, like half a dome.
The equatorial circumference is like the only thing that can be equal on both projections. It's the same line, and it's always ever been inferred by sun angles, right? 360 degrees divided by 7.2 times the mystic 800 kilometers to get the 40,000 estimate back from Eratosthenes. That arc, that 800 kilometers, that's the only thing that matters. Otherwise, you got a ratio of a circle, which is just an abstraction. It means nothing. If you're calculating a 1/50th of something, that means literally nothing unless you already know. So the whole thing is, how do you know the distance was 800 kilometers? That's itself an aspect of the graticule, because he was, of course, making maps. And, of course, they had a previously known estimate based on the maps, based on the projection that Earth was a sphere. So it's circular in the first place. But if you didn't even know that, it would be the same on both models. So arguing that it wouldn't be the same on Flat Earth is silly. The only difference, of course, would be going south and trying to measure to the surface of the Earth and try to match that to the projection.
Well, either the equator.
Jeremy. Hold on, Jake. 1 second. Jeremy doesn't like the idea that the distances are the same on both representations.
Well, it's just a unit conversion to be the difference. It's internally consistent. So if there wasn't a kilometer and we just had the Chinese story and their original rope, we would relate the same thing and all of our units would be in lees. Now suppose some guy comes along and says, "Hey, this rope situation's kind of dog shit. Why don't we use a uranium bar or whatever of a specific length at a specific temperature?" And they relate that unit of measurement to the angular change of the coordinate system for Polaris, and then they define a meter as a ratio of 1/10 millionth of the distance of this arc. So 1/10 millionth of this arc is what they defined the meter as. So it's the same thing. So to get the difference between our system and theirs, we just divide our circumference by theirs, and then we multiply that ratio or that factor by our units of measurement, and then that gives what the familiar distances are in kilometers and stuff. It's internally consistent to itself. So it's not that there's two different distances and they're equal. It's that they're internally consistent to themselves, and you can use a conversion factor between them to convert the same way that you would convert an inch to a kilometer. All they do is divide an inch into a kilometer the same way that we divided our circumference into theirs, and that factoring difference is what we multiply by to get kilometers or meters or what have you. So
could you actually show that because I doubt there's a lot of globers that understand that that's where meter came from.
Yeah, but can I just say really briefly, but the difference in distances, like Antarctica as a continent, like it was on that dual pole projection one, versus Antarctica as a ring around the outside, like just the circumference of that Antarctica there on that dual pole one, the circumference of it versus the circumference of like the AE Gleason's, like the single pole where the Antarctica is the ring around the outside, wouldn't that just be a dramatically different number of the actual like physical in real world circumference of Antarctica in those two?
Not when you're referencing it from the projection. It would be symmetrical. It would be the same. Even though it looks like, even though this looks much bigger because it's the entire circumference of the circle and it looks huge and massive, and then this looks not so big. Well, if you drew a circle around them, they would be the same size. They would be the same central angle. I was trying to show that earlier, but the central angle thing isn't showing up correctly on here, so I'll have to fix that. But if you took like, a 15-degree arc in the north, and then, well, it's not showing the lines correctly though, so it's not. I mean, like we can do that though. So it's like if I go to flat Earth and we take this distance. Why is it not let me click? Hang on.
Refresh. Yep.
Well, that's that whole argument people make about like Captain Cook, and he claimed that he went around like 50 to 60,000 miles, and then that was always said to be sort of a supporting thing for the AE or Gleason's map, that it was much longer, much further distance than what the globe claims as a continent on the globe.
Yeah, but if you look at his route, wasn't he going like in and out of places and doing like, didn't he have like a hell of a path to how he was doing it? He didn't just do like a straight circle. He was going like in and out, did some back loops, if I'm not mistaken. I can't remember.
Probably drinking out at sea, zigzagging all over.
This is why I asked you to draw a square though, because you said like the distances didn't matter on which one it was. So
yeah, it's still going to calculate
it doesn't even matter.
distances.
I mean, I understand what Alan is saying. It's saying it's a projection. That's why what he's basically saying is on these projections, it's not a fixed unit of value across the entire map. Like as you move to different parts of the map, the unit for each distance changes, right? It's not a fixed distance across it, right, Shane?
How long it looks isn't how long it is.
Right.
It's
That's
the-
why Australia,
Like-
Australia looks twice as long as the United States, but we know that that's not the way it actually is. So on that map, as you go to, on the projections, the scale is actually changing across the position of the map.
Well, there is a map you could put on. That would be
The visual,
all
it's the
that.
visual scaling though, but the actual central angle would be the same. I'm trying to show that now. Hopefully I can get this.
And we
But you
get
agree, Shane, that if
distances-
we
hold on, man. Go ahead. I'll wait. I'll go next.
Okay. You agree, though, Shane, that if we do live on a flat Earth, the circumference of the Earth is either 25, or the circumference of the equator is either 25,000 miles, and then the distance from the equator to the North Pole is 6,250, or it's some other value, but it cannot be both, right? Because if you take that divided by pi, it's gotta, pi divided by 2, it's gotta take you to the center of the pole, which would be like 4,000 miles on a flat Earth with a 25,000 mile circumference. Whereas on the globe Earth, you can have a 25,000 mile circumference and, a 6,250 mile distance to the pole. Those are kind of mutually exclusive. You can't just apply a coordinate transfer.
Where did you
and
get all
explain
that from?
No, so he's getting all that
That's
from
geometry.
that meme. Yeah, well, he's getting all that from the meme where they're misapplying a line of longitude as a radius value, which we went over earlier. Those two are not the same thing. MX, I'm gonna mute you for a second. You're hot micing. But those, let's see here. What were we just talking about before the hot mic? It was what were we just talking about, Les?
Distances.
Oh,
I
yeah,
think.
right. Yeah. So yeah, you're getting it from that meme right there, which we just covered, is misusing the meridian line as a radius value. A geodesic is curved; it can't be a radius. So we would never argue that. We're arguing that the arc in the sky is what defines the distance for the change in angular position of Polaris as they traverse the land. So that, as defined by the arc in the sky, is going to be the same as when they would say, oh, we're on a sphere and we're traversing the surface of the sphere. You're referencing the wrong thing to make your argument. It's not our position.
Well, no, people go out on sailboats and planes with a fixed speed, so they know how long it takes to traverse a certain distance.
Jake, that has nothing to do with the argument that you're making. So,
nor with the
Sure it
model
does,
really
because
as doing it.
nope, not at all. Because if you understood the argument to completion instead of just repeating that, you would see what that arc in the sky represents for the distance traversed on the ground and why that would be equivalent over a flat Earth if you had imposed symmetry for two hemispheres of vision linked together at a central midpoint. So you're misapplying the geometry of what you're representing with using a meridian line, which is a curved, it's a longitude line, it's a geodesic, it's curved as a radius value, and then multiplying it out. That's not our position or how we would reference distances on here.
Yeah, but Alan,
but we
if you get on a
can.
boat,
Yeah,
Still going.
yeah,
All
but
right.
nothing, dog. Yeah, but nothing. Jeremy, what's up?
You can get distances on these flat maps or projections or whatever you got, right? We can't get a ground distance from A to B.
Yes, sir.
All right.
Got a question.
I'm
Yeah,
just
I know
saying
you were kind of joking. Go ahead,
real
Jeremy.
quick, those distances can't be the same as a spherical Earth, though.
They
Right.
come from a spherical coordinate system that represents an angle as an arc length, and then it relates distance by multiplying the radius by the arc length. So in our scenario, our radius value is defined in lees. When we multiply that by the angle, we get a distance in lees. So for the arc that I drew here on the AE map, which let me make this darker so you can see it better. So for this arc here, that's let's see, what was the arc length on it? I can't remember, but anyway, it comes out to be 13,539 lees. And when you convert that into kilometers, it's 4,222 kilometers. If we look at it on the glurb, same exact angular relationship. We look at it on the dual pole, it's not displaying the arc length correctly. It's like not rendering right, but same arc length there, same exact angle, same exact distance represented over that distance. It's invariant under all of them.
One of
that's
the
just how it
distances.
works.
Yeah, but
They're
that's
all the
not how
same distance,
geometry.
Jeremy.
That's not how geometry works, though, because if you had a distance on a globe versus a distance on a flat Earth, there can't be the same distances. That's why I asked you to make the square, because if you make a square and the diagonal has to be the square root of 2, but it won't be on a sphere. So if all the distances are the same, like somebody's distances are definitely wrong.
That's a ratio.
So Jeremy, we're using a spherical coordinate system. So however fucked up the square would be when you reference it in straight lines on that, it would be just as fucked up on the other projections, just as proportionally. So it doesn't matter. Calculating two distances between any 2 points on it is done using the same arc length, which if you do it in the north or the south is going to be the same angle. It's not going to be a different angle regardless of the projection.
I know, but you understand if you make a. Just hold on a second, man. I waited my turn. It's my turn now. You understand that if you make a square, right? If you do one on the globe and then another one on a flat Earth, the distance of the diagonal can't be the same. If the sides were all the same, the diagonal cannot be the same.
Well, do you understand that even on a flat Earth, we're still using a spherical coordinate system to relate distances to compute them? So there's no, like what you're talking about is kind of like it's a non-point. So all we can do is reference distances. Yeah, but all we can do is relate them internally to the coordinate system that we're using, though.
Yeah, Jeremy, they follow the latitude lines. So those distances are all going to be like when you're saying draw a square, what latitude line are you drawing a square off of?
So square can be the square can be anywhere. It doesn't matter where the square is. It could be anywhere in the middle of the ocean, on land, whatever. The distances can physically not be the same on a globe versus a flat Earth because the diagonals will be different of the square.
What about distances like
luckily-
dual pole Antarctica? If you get a box around that compared to the other one?
Hold on, man. Let Alan respond to that.
Yeah, it would still be the same. And
Jesus, guys.
And drawing boxes, the boxes would be comprised of little arc length segments So it would still calculate out the same way. And if the diagonal line between them came out differently, that would be a product of using a spherical coordinate system to calculate it in the first place. It wouldn't be a feature of the ground being like, being fucked up. It's just a product of using a spherical coordinate system.
These distances, they're on the ground, right?
Yep. But they're defined by a change in position in the sky as an arc. Like, that's how they relate the two.
No.
The distances you're talking about, you have to measure between latitude and longitude points, between coordinates at that point. And then Jeremy's talking about squares on the
Sounds like a
surface
white
of
knight.
spheres as if that exists. It's very strange.
Geez, Alan, you don't need a white knight, do you?
I got a question.
Watch eclipses again.
I mean, if you don't like the square, you can make a circle and then have a radius to the circle, and that'll tell you if the surface is planar or not. And if it's the same as, if all those distances are the same as the globe, and like I said, some of these different distances are definitely wrong.
Yeah,
In
it
fact,
has
we
to
can
be.
know,
Yeah,
we
that's
can,
true. Yeah.
yeah, we would know if the planar
Guys.
one's wrong because.
Guys,
What's up?
That's why,
you guys are
spherical excess is basically linked to that as well. That whole concept.
I think it's a category
and
error, Alan, but go ahead.
It's a product of the using a spherical coordinate system, the spherical excess. Like if you took 3 azimuth locations on here and then summed them, they would give spherical excess, but that's because the coordinate system that it's referencing is spherical, not the ground. And the distances being different under different projections is incorrect. They would all be the same. They're all linked to the same central angle. If like to disagree with that aspect of it is like I don't know how to rectify. I don't know how to rectify that.
It comes from the
Here, you
astronomical
keep-
triangle that gets transferred to the terrestrial sphere, which is why it's spherical in the first place.
I know, but we're just talking about ground positions. And when it comes to the ground positions, however you got them, I could care less. But we can definitely tell from the ground, the distances on the ground, if it's planar or not by the diagonal through the square or pi or the radius of a circle or something like that.
What distances are we talking about?
No,
Jeremy?
Yeah, are you gonna use miles?
No, because we're still referencing fucking units of measurement derived from the spherical coordinate system, and then positions that we're relating are defined by the spherical coordinate system. So no, it wouldn't. I can't. I don't.
You could do that with the lees that he did. He did all that and he put it in measurement of lees, which is more than a wee bit, and it's a lee.
That's the whole
It doesn't matter if it's in giraffe necks or baseball fields or whatever the distances are. It's impossible for it to be planar if pi doesn't follow or the diagonal of the square is not the square root of 2. Like there's certain geometric properties where we can tell if they're on a planar surface or not.
The scale of a baseball diamond is not the same as like long distance using the actual coordinate system where you would have a depreciable difference. It's not the same thing. It's not analogous.
Can I ask you what?
I guess the problem is I don't think any glober would use flat Earth, models to prove the Earth is a sphere. So why are you applying sphere Earth models to prove the Earth is flat?
That's not what he's doing.
Well, actually, this system came from the Chinese before the spherical Earth doctrine was presented, and it's based off of a hemisphere of vision that an observer sees. So the same concept that we've been arguing forever, and then how
The same
everything
concept
is
we're using globe Earth data points.
Yeah. So if you're so 1 second, if I'm in the middle of explaining something and you're going to interrupt me just to say you're using globe stuff, like we can just forego that, and then you could just say globe 3 times, and then we could just skip to another person. So what I was trying to explain to you is that the Chinese were using this system as geocentric flat earthers long before the spherical doctrine was cast upon the entire world. And this, to show what we're doing here, is showing that using internally consistent ratios of a coordinate system, you can make the exact equivalent for what you think is the globe when you reference the coordinate system. So if you want to engage with that aspect of the argument, that's great. But if your argument is you look up in sky, therefore a globe, I mean, go ahead and just say that 3 times, and then we can just we can move on. Go ahead.
Right. Didn't you say that you got all your coordinate points from a globe system and you applied them to that flat planar model?
Nope.
No.
He's made a
I could
multi-model.
have sworn you fucking
No,
said
no,
that.
no, no, no. He
Nope.
made a
Spherical
multi-model,
coordinate system.
multi-projection tool. Everything that it does for the FE, it can do for the globe. This is beyond FE. This is just. Does that help you, Ms. Stride? This isn't.
No, I'm
This,
wondering
this
where
whole
you got
thing's
your
not
data
centered
points
around
from.
FE. It's centered around this tool, which is multifunctional.
Okay, that's fine. He's got a tool. Where did you get the data points to enter into the tool?
Guy.
Is this like? Is
So
this?
you-
Is this
so-
like the
so-
final question?
so-
Is this leading?
So 1 second. Positions in the sky over time. Ephemeris data. That's all it is. So your argument is about to devolve. Yeah, is your argument's about to devolve into you looked up in sky, therefore globe.
Can I ask a question? We can skip this guy.
What's up, GOC?
I wanted to ask a question after him, but go ahead, Gio.
Yep, go.
Thank
you.
First of all, nice job, bro. Congratulations. And also the Flat Earth community appreciates all of this work that is hard, long work that is put into actual work, bro. My question, do you know Hervé Riboni? Did you see the video of him and how he explains?
Oh, yes. I was actually, thank you for reminding me of that. That's something I have to incorporate into this and see what,
Oh my God, please.
how that
Hold
works
on,
out.
hold
I totally,
on, hold on.
so
Hold on.
yeah, go ahead, go ahead.
Did you see what he said, and do you actually believe this? Because I can give you a good example on how they, use it in their. I'm not saying that magnetic declination doesn't exist. I'm saying that they use it in their benefits in certain places to hide stuff. If you understand what I'm trying to say.
Yeah, I could see that being a thing for sure.
Because if you see how they do it in the north, on how the closer you get to the north, you have to adjust -10 and then -20 and then -30, 40, 50. And then you're not going into a straight line anymore. So let me give a good example. If you're like a captain sailing in the seas and you're heading 0 degrees to your
Not believe in gravity or like what's going on?
and you're
You got it. Hey, ask the question.
you're correcting for magnetic declination, negative.
Yeah, so you guys don't believe in gravity or what?
Hold on. I muted him. Continue, geocentric. You're good.
Yeah, and you're not going into a straight line anymore. So you're curving around the center, and then you're going back because when you're coming on the side of like Russia, closer to Russia, you're doing the opposite. You're doing -90, -80, 70, 60. So the whole magnetic declination map, you can see that it's hiding some things. And also, if you're sailing south, going in between South Africa and South America, your map is correct because the Gleason map, I believe that the Gleason map has some errors, but some people don't see it because of this magnetic declination problem that people don't actually get. Is that the globe shows the South America beyond Brazil, of course, the borderline it shrinks. So if you're sailing down south, you still have to go right or west in order to reach the border. But because on the flat Earth map, the southern part of South America is skewed to the left side, they added that -20 to that negative, I think -10 to that -20 magnetic declination in order to move the borderline of South America in order to stretch it a little bit farther to the left. You understand what I'm trying to say, right? I don't know if you've been
Yeah.
you dove through this. Okay.
Yeah, I've
No,
seen
this
some
is all what I came up
visualizations on that
with, bro.
too. Yeah, I'm gonna have to add the magnetic declination map to the thing so we can see that kind of stuff and compare it.
Thank you very much, bro. That's all what I wanted to. I wanted to see if you're up to date with that, or you've seen this and you think it's they're actually using it to the benefits in certain places.
Yeah, I will look into it more. I totally forgot about the Hervé Riboni stuff.
Quick question. Out of all of this, Alan and Shane, what did you find the hardest to explain when you were going through building this?
Let's see. I think probably, when I first started it and modeled out what the 24-hour sun looked like, I was like, oh man, that looks, that's a rough one. That I can see why all the globe lads are super into that one. But then after seeing how directions, change when you change the projection type and how this God's eye view, plays into it as well, it got a little easier. But I think that's probably the most quote unquote difficult thing. That's the one that everyone
just
wants to
see
get an
it.
explanation for the most.
seeing the world from God mode is the weirdest thing, and then trying to justify that as a perspective when all you ever see is the opposite of that is really hard, I think.
Yeah,
Did you? Was that your?
Oh, sorry.
Was that your answer, Shane, or was it just going in line with what he said?
Yeah, well, same thing, sort of.
Okay.
But specifically,
So-
God mode. God mode is weird, man.
God mode was a
Appreciate it.
huge revelation to get the
It's
difference
weird.
between the two. Because if you go to Bislin's model, you can see like it has the actual dome thing over it, and then it has like what the observer sees, and it's hard to separate those two together when you're looking at it when you're looking at them together. And so that's why I wanted this to be something that you could toggle to kind of see what it looks like proportionally and whatnot. And Bull Knight asked,
What are those green things that are flying around outside of the observable dome?
Satellite.
those green those
Yeah.
those green things are satellites plotted on the celestial sphere.
But why don't they stay within your dome of vision?
Because you have a limited vision, so it just converges to the horizon at a certain distance away from you. So
But
Bull
those
Knight
stars
asked,
don't. That's weird.
well, the stars are doing the exact same thing, though. It's almost like you haven't even looked inside of the thing at all.
No, I'm looking at your model right
So-
now, and I'm looking like underneath the plane of stars, and in between that and the planar Earth, you have a dome of vision that the stars are reflected in, but the satellites that somehow go outside of that you're mapping. Why don't they also get reflected into your dome of vision if they're beyond your eyesight?
They are. They're in the dome.
Not
of
in
vision.
your model. No, they're outside of the dome of vision.
Check out the stream.
So that's just a visual bug or whatever. They're when you're looking at it right now from inside of the perspective of someone watching the satellite in their field of view. If you,
Oh, because I was watching it from my God's eye. So I was on the outside there. I'm seeing him zip around on the outside. Just why isn't it modeled correctly there?
Yeah, so like if you see, this is just a visual bug, like this right here.
Oh, so you got some work to do still?
Well, I mean, everything else works fine, so it's just all I have to do is just, it should be fine.
But that little thing ain't working, right?
Correct. But yeah, you can see here though, they're going over top, doing their same pattern, and that's just how you perceive it in your dome here. So Bull Knight asked, yeah, go ahead.
Sorry. I was gonna say you just
Bull Knight.
actually made me think of a
Fucking
no, I know, and then I you're fine. Go ahead. You first.
Okay, I was gonna say Demon Stride brings up a interesting thing. We should have a bug like a bug report, and have Claude fix it. Like,
well, you can actually report bugs on the GitHub. Yeah, so there's that feature exists on GitHub. You just go here and go, I think it's pull request or issues or something, and then you just fill out the thing. Oh yeah, new issue. You fill it out, and Claude will take care of it.
Somebody put in a request for me to add to settings a screen drag invert button.
Yes.
Oh yeah, I forgot he said that. That really bugs him. I forgot about that.
Yes. Yes, I will add it.
Can I fork
so let's
this?
see here.
Bull
Yeah,
Knight,
absolutely.
a question from Bull Knight.
Yes.
Yeah. So Bull Knight had a 1 second, lads. Follow-up question from Bull Knight. He said, what was the biggest surprise from this modeling? So the biggest surprise, although it was kind of the most expected outcome, was that when we added the Lees and ratios to give everything meaning to the unit sphere, it was seeing it all work together and like exactly how we've been arguing it was it was a really cool experience to see that, to see it, like it was kind of mind-blowing. And then this was added to the spreadsheet here. so you can also take any Earth radius value or whatever radius value and convert it, get the Lee conversion, and it'll always work out proportional because that's just the nature of the using internally consistent ratios of a system. Seeing that all come together was pretty eye-opening, I guess. Even though
all of our positions were correct. Is that what you're saying is the most surprising part, that all of our positions were correct? Because that's what you're kind of saying.
Yeah,
well, there's definitely
like there's a difference between knowing that the ratios would work out that way and seeing it on play out through a simulation, and seeing that play out. It was like, oh wow.
Yeah.
Yeah, it is amazing how it was able to all come together and to be able to see all these. This is like a really awesome tool that you made. Good work on many levels. I was gonna say, okay, if one of let's say of these 4 projections though, if there is one of is one of those what God mode could be? Is that a question that could be asked? Like, which one would be the correct God mode? Because they
That
are
is
different.
the question. That is the question at hand. Which one of these is the correct God mode? I guess would be a good way to put it.
Yep.
And we have to. The only way we can test it is from down here, but from observation alone, it looks the same on every single projection.
Right.
So it runs
So
into
that's
a
unfortunate
curious
and it's
situation.
hard.
But
Yeah,
yeah,
you
that's
know who
essentially
does know?
the issue.
Yeah.
Who's that?
You know who does know? God, bro.
Did you use a
Oh,
Blender?
the old homie in the sky.
Well, I mean,
What's
I
that?
guess God. I mean, because you guys were using the phrase God mode, but like, I guess it would just be which one is the truth, ultimately.
Yeah. Yeah.
Did you use Blender?
Yeah.
What did you use to make this? Is it just Python?
So this is all done in JS3 or 3JS, something like that. It's all done from JavaScript, essentially.
Oh wow. Okay.
Yeah. And then
Remember
you could play
when
it right from
I
the
showed you
browser.
remember when I showed you my representative model that you corrected me on the spin of the Earth? Well, the spin of the sun. Excuse me.
I can't remember.
Yeah, it was pretty. Yeah, you have a lot of. Yeah, anyways. Yeah, I use Blender. Does that ring a bell?
Blender's
Kinda.
not as universal for people.
Yeah. It was just a representative model. This is more like scientific, all statistics and stuff like that. Does this have also like the three different the Tropic of Capricorn and the Tropic of Cancer?
Sure does.
Yeah, I was
have them
turning
turned
those
off
on.
right now.
It's actually, yeah, dude, those settings are great. Like, yeah, it labels them. Yeah.
Oh
Yeah.
Perfect.
Yeah. There's so many features you didn't show. Actually, we should probably.
Yeah.
Sorry.
Tune in next week.
South to north. Whatever.
By the way, Alan, did you
Ooh.
see my message? Oh, that looks crazy.
Look at the sinusoidal path of the sun. That looks a lot like those those crazy dudes who think everything teleports with no explanation everywhere when they have a model. That shows a map. They like how things teleport that way. Should we do a quad pole? Is there a quad pole variant?
I was trying to find a quad map, but the thing is with this tripole one, because it doesn't fit in like a circle.
I
it doesn't
figured it out.
line up
Just
correctly. So like the observer will end up out here instead of being tied to the actual line, or like to the visual scale of it. So it looks a little messed up. But we could add one.
What would be the justification to even consider a triple pole?
It's just for funsies and just to show that what these look like under different projections and how they still remain the same for what the observer would see. There's no real justification for it. It's just kind of showing conceptually that these all represent the same thing, regardless of how the God's eye perspective of it looks. What the observer sees on the inside is the same for all projections.
Doesn't globe
but the
have,
justification
like, 10
for a
north
dual
poles anyway?
pole.
Aren't there like 10 north poles on the globe anyway? Yo, Alan, I got a hard-hitting question. If you're ready,
what do you got?
You can handle it.
Hold on, can I finish the justification for the dual pole is because there is an actual physical South Pole place, right? So
that's certainly asserted, but as we went over earlier, it was a calculated reference point that the Chinese used to set, not an actual place that anyone traversed. So what's in contention here is that
but people go there today.
So, like I was saying here, there's a possibility that this has its own continent and the ice wall is something else, and it's just something to consider. These are all just conceptual overviews. There's no need to justify anything. So,
I mean, if we're trying to figure out what it is in reality, then some justification is required.
Yep.
Well, you can't make the
tools to help us do that.
Yeah, and a big point of that is using a God's eye view of the projections doesn't actually really tell you anything unique. Some of the things
forget about the projections for a second. There is a place that people go.
I'm good.
Okay, surrender. Thank you.
Surrender. There's literally 3 north poles.
I think what he's saying, he's saying though is like he's just explaining like what actually happens and that there is some sort of justification that needs to revolve around that. Is that right, Max?
Yeah. So based off of the observation alone, though, you wouldn't be able to tell the difference, and that's the point. That's why when you go into first person here and you track a
Yeah,
position of a
but
star and you look at it and you toggle through different ones, you see that it's showing the exact same thing. The overall
like
God's eye view difference here has to be tested through another means. You wouldn't be able to tell any difference just from looking in the sky from an observer perspective.
Like, I don't know if you guys have heard us argue anything ever, but we argue kinematics and dynamics all the time. We argue observer based with a fictitious observer all the time. So kinematic versus this is a kinematic model. It displays observations. You know, the one that I ripped off it specifically does kinematic epicycles from Ptolemy from way back when, and only that. So we're always arguing the same thing, right? This is why it's showing our position was accurate, as we were surprised to find out.
Just one thing. This may be irrelevant and unnecessary, but think about it like this: if we take America as far as we measure it, and we could imagine it in our minds, and we were to warp America around the entire outer edge of the flat Earth, what would that do to like measurable distances, to people who drive across the place, airplanes that fly across the place?
Absolutely nothing. It would still be the same distances. It would just visually look like a different distance because it's stretched out on the projection. Do you like how the size of these and how they look and stuff isn't representative of how the central angle is the same?
Oh,
So
let's just. I promise, I'm not trying to debate or do any of that. What we're looking
no,
at
you're
right now,
good.
as far as the Gleason map goes, if we were to, I'm not asking you for any numbers. We're just trying to get an idea. If we were to make a trek, with our little drone around the coastline of Antarctica, all around the world, that's got a real distance to it, right? We got to account for battery and all the things we got to account
Oh,
for. Battery is a huge
I
one.
sure,
So
okay.
if we get that same drone to go around that coastline and go all the way and make a circle, compared to if you just swap it to the dual pole one real quick, and then we'll end it. As far as me, I'll end it right there. And then the
Yeah.
dual pole. Okay, we get the drone and it flies around that Antarctica here. This is just what I think, and the distances can't be the same. The actual amount of ground it's going over or coastline or whatever, it can't be the same, because then it would lose meaning of the outer edge or small continent or large continent. That's all. That's all.
Yeah, and actually I think you're kind of right about that. So in reality, like there would be a different like the Urbe Rabboni stuff, if we took that and got like a different distance out of that, then like yeah, that would show an asymmetry in what should be a symmetrical reality. And then in the cost of having like Antarctica be its own thing and then the ice wall be a separate thing versus the original projection, there would be a distance difference. But if you, yeah, so like the way that I was looking at your question at first is if you just, drew a line around it, and then like reference the same line, that would always be the same. But if you actually were like measuring it in some way, through ship or like a drone, you were saying that could lead to asymmetries in the distances where you'd be able to actually tell.
Thanks again. Thanks.
We're not doing a dynamic model. We're not saying, "Hey, look, we've predicted how the motion of all the bodies in the universe in the sky. We know how everything moves." We're saying, "Here's where they're going to move for you, given a specific location," and that's all it does, and it does it really well.
We share the Haversign
Okay, but if
formula.
it's not a ball, then how can people put
Absolutely.
barbershop sticks in the ground in the snow? So
It's a good question. They
now
are
what?
located somewhere on the coordinate system. Let's see
Well,
here.
the South Poles, quote unquote, you can put infinite of them. People don't understand how big the 90 degrees south is, or 89 degrees south. Like the difference between 89 and 90 degrees south, there's a lot of stuff there. The difference between 0 and 1, there's a lot of stuff there. So I don't think anybody's actually, trekked out into the frozen abyss wilderness and, marked the exact spot where the South Pole would be. It'd be more like a area of where you could put your little barber shop sticks into the ground. That's what people usually do. They bring their own.
It exists. They've been there.
Yeah, like the thing about the South Pole is not that they stuck a barber's pole in the ground. It's that you can get there from Southern South America or South Africa or Australia in about the same amount of time for each. And it doesn't really make sense if it's anywhere that isn't a real geographic South Pole.
You bring your own though. If you're gonna take a picture at the quote unquote South Pole, you bring your own.
But you don't bring your own like Amundsen Scott research station that's right there. Like the research station at the South Pole is not something you're carrying in a backpack.
And how do they determine that that's antipodal to the North Pole, and which North Pole there's 10? So that's like the issue with the whole South Pole claim, is that it's really just we're taking the North Pole, we reverse engineer it, and you pick which one because there's 10 North Poles, and then you say this one. There's 10 North
The
Poles.
poles actually change. They're not in a fixed location in the north.
It's an arbitrary point, man. There's 10 different North Poles.
Yo, I will be right back. Shane and or Gally or Piezo. So cover for me.
Gally, are you saying
nice?
Can I try to steelman what you're saying just for the discussion, Gally? Like, are you saying from different perspectives, you are experiencing the same North Pole but in a different way?
No.
Okay, can you explain?
Well, actually, let me ask Gally a question. If there's a little pause there, Gally, do you think there's a GP of Polaris, a ground position under Polaris?
Yeah.
Okay, and then when you go to like the equator and then start going south, and there's the southern rotation, and then there is the very faint star there, Sigma Octantis, but you can also use like the southern pointer stars and the southern crux, and you can create like a triangle, and then you can get the center of the celestial rotation. That's the way to do it. Like if you're going to take elevation angles from the South Pole, because Sigma Octantis is not very dependable. But anyways, do you think there's a GP there underneath that?
Yeah, it's a lot harder for our folks in the South because they're not Polaris privileged. Like the northern folks, they we call the northern folks. They just look at one thing. In the South, you have to take, was it Sigma Octantis, the Southern Cross. You have to make a T kind of shape, right, with the two dots, and then do calculations. It's a lot harder when it's like second or third step. And so, all right, I'm gonna finish my point. And so when most people say South Pole, they're claiming something is antipodal to that point where Polaris is at your zenith, and Polaris is at your zenith for a giant area of space.
Okay, so I'm saying like the southern crux and the Sigma Octantis and the center of that celestial rotation. Do you think there's a ground position underneath that as there is at the one in the north in terms of Polaris? Do you think there's also one in the south? Because we see that rotation, which in a lot of ways looks similar to the north one, in terms of like its kind of general motion, different stars, of course. But so do you think there's also a GP at the center of that?
I'd say it seems like
celestial
it.
point?
I'd say it seems like it, but there's so much you have to do calculations once you're comparing. Like you make like the cross and the T. These two dots point to this dot, and then it's somewhere in between those two. And then if you can get that at your zenith, now you're in an area where you can call the South Pole. But it's not like it's like a calculated average.
Well, apparently,
yeah, like sake of argument, you've got a telescope in now.
Apparently, ALE, that company, ALE, the ones that also hosted the trip that those guys took to the Union Glacier. But that same company, they have a camp at the 90-degree south point that you can go to. But those trips, I think they're like 80, 90,000, some of them 100,000 just for one person. So they're way more expensive. And then they also have something called Ski the Last Degree, where they take you to 89 south, and then you literally ski 69 miles or 60 nautical miles, for 1 degree. You ski 69 miles to the 90 point. And that's like a trip they offer as well. I mean,
even that I would be hesitant to grant, because how do we 60 nautical miles or 69 statute miles in
I
the
mean,
south.
someone
How
needs
do
to
we
take
mark
that
it?
trip. Yeah. Go ahead. Sorry.
There's-
I was saying someone needs to take
there's
that
g-
trip. That's sweet.
Yeah,
Yeah.
I like skiing and snowboarding, but I'm skeptical of that even. I mean, how do you know that it's the same thing in the south as it is in the north? We get that 60 or 69 because we're Polaris privileged. So we're able
Well,
to, because we have PP Polaris privileged, we can 69 in the north. They can't do that as much in the south. It's a lot harder. They're not as Polaris privileged as we are.
No, but you can
Well, again,
you can still use the
you can do it with
celestial
any
center.
star.
Yeah, you can still use the celestial center rotation point. You can still do it in the south. But I guess so in terms of the 24-hour sun, when you go to the north, you know how like if you get to the peak of the solstice points and you're getting it to where, let's say you're at the North Pole, the sun would just stay at like 23.4 degrees elevation and just stay at 23.4 the whole time, meaning it wouldn't go up and down like a sine wave type. Where like when they were in Union Glacier, it seemed like it went down to like 13 degrees, then up to like 32 degrees, and then back down to 13. I think it was in that range, throughout the day. Well, but when you're at the 90 degree point though, at that time of year, the sun would just stay at 23.4 degrees. So if you were taken to a place in the south where you saw a 24-hour sun that stayed at 23.4 degrees elevation angle and just perfectly went around you, would that indicate that you are at the 90 point?
I'm not sure. There's all types of problems with the sun in the south. I think Michael Brenner has a bunch of that chart out because when the people start experiencing the 24-hour sun observation in the different camps, it doesn't seem to comport geometrically with any type of model. There will be people in camps that are where you'd expect them to already see the sun, but it takes them like a week before they start seeing the 24-hour sun. And then there's people that you'd expect not to see it and they see it earlier. I think it's Michael Brenner. He mapped it all out. I'm trying to find that for you. But the sun in the south also, it's not like an equivalent as it ought to be if Earth fall. I'm not sure what you're asking because I was in the middle of speaking, but I was almost done speaking.
No, can we let him finish real quick?
I did. So I think Michael Brenner has mapped it out. It doesn't comport to how uniform you'd think it would be on a ball in the north at all, actually. And I said I was going to look for that.
Yo, I had a cool idea. Can we put this final experiment being fake to the test with this model here? Can we put an observer kind of near wherever they were and during that time of the day and run a 24-hour and see where the star appears in the model at least? And then we'll see if it matches the video, and then we'll see if it's fake or not right now.
Matches the video. So in terms of like matching the video, I don't know what you mean
Generally.
but
It's a 24-hour sun. There's no nighttime and no stars, dog.
But yeah, in terms of the azimuth though and the time, everything should be correct. And regarding the Brenner thing, Gally, if I'm not mistaken, I think Shane plotted those out, and I think Mr. Brenner was mistaken. If I'm recalling correctly, Shane.
Did I? No, I didn't. I didn't do anything of the sort.
Are you able to put the observer in Antarctica on that model?
Yeah, he's right here. She's right here.
I think you might be conflating it with what he did for the Antarctic base stations and the times at which they experience solar noon in the south.
Space Busters did that? Is that what you mean?
No, Brenner did one. Brenner did one, and Space
Brenner.
Busters did another one. I think the Space Busters one was the one that was incorrect, and then the Brenner one is a separate thing. I don't think anyone's checked that one. Maybe.
I posted in the chat. Actually found it. So I looked at Piezo's posts on AC, but so this isn't a high quality version, but basically he goes into all the different bases, and when they start experiencing the 24-hour sun in the south, and it doesn't comport to like uniform antipodal what you'd expect. So if you were to say like it functions the same way in the south as it does the north, first you have to define north because there's 10 north poles or 9. There's 9 north poles, and then you'd have to say it functions the same as one of them.
Ooh, you know what? You know what I'm gonna do? I'm gonna add all of those bases, all their coordinates, and then we'll sim it out and
Oh, so
see
you have
what
the
and see
Brenners.
what
I'll
happens.
just send it to your DMs.
Yeah,
Are you talking about the
I-
magnetic?
Oh,
Are you talking about the magnetic pole or the celestial? Because yeah, the magnetic does
the
change.
celestial
They
pole.
claim.
I'm talking about the 9 North Poles. There's
Well, I mean the
the
GP is
geographic
Polaris.
one. There's the geographic one. There's the celestial pole in the north. There's the magnetic North Pole, the dip correction. There's the geomagnetic North Pole. There's the magnetic north, which is just a direction that points. There's grid north, which is a projection-based north. There's astronomical north, which is equivalent to true north, but use it differently. And then there's a polar motion pole. And then there's just a cultural North Pole. That's where Santa is.
Like 8 of those are the same thing.
No, they
Those
don't.
are all. There's magnetic north and there's geographic north, and like celestial north is geographic north is the center of the Earth's spin, which is why it's the celestial North Pole in the first place. Like,
Then there's the
you
pole
can get
of
into like,
cold. Then there's the pole of inaccessibility.
Wait,
Oh,
no, they
Alan,
don't all. Hang on, they don't all map to the same place. Only 2
and
of
let's
them
not
are
forget about the pole
projection.
dancers.
I know
Like
this triggers a lot of
and
people.
This is
no, like
Perth
because it's stupid. Like
They're not
yeah, like
all. They don't all map to the same spot. Some are projection based. Some are positions in the sky. Some are model based. Some are directions. So to say they all map to the same spot makes no sense.
Yeah, I'm
All
looking
right,
at the stuff
lads.
you shared in the chat, Galley. 1015 with the charts, like San A4 and Troll Station. San A4 is only 26 miles further north than Troll Station. 26 miles is like a third of a degree or whatever. However, its day length on the same day is about 42 minutes different uh, than Troll Station. So like 26 miles does not equal 42 minutes.
Can I
'cause
address that?
Sure.
Okay, so I've had a look at this thing that Brenner did quite some time ago, and so there are two things you have to deal with when it comes to predicting and measuring twilight in Antarctica and sunrise and sunset, but particularly the twilight, which is what he's talking about here, right? Is that the angles are very shallow, and to mathematically define twilight at those shallow angles, you have to be very precise. And if you use a subtle, any subtly different definition of calculating when twilight will occur, whether it's astronomical or aeronautical type twilight, you can have a very large range of values. And in particular, you may find that you actually it's an iterative algorithm you have to use to find twilight. You might find that you converge on a value that is quite different to what you would
Bro,
observe potentially, right?
that's not what he's doing. Like it's literally right there in the chat. Go look at it. February 1st, they have a midnight sun at Troll Station, and February 2nd, they lose an hour and 17 minutes of sunlight.
So what's
So
his definition of daylight and sunlight in those
well,
charts?
midnight sun means the sun is above the horizon. So it
Okay.
doesn't matter. It doesn't matter what his definition is because if the sun is above the
does.
horizon for hold on, I'm talking. You need to not interrupt. So if he has 24 hours of sun continuously above the horizon on day 1, and then on day 2 there's an hour and 27 minutes or an hour and 17 minutes where the sun is not above the horizon, that does not match the heliocentric model. You don't gain or lose an hour and 17 minutes in one day on the calendar.
Was he used the same definition? Is it the upper limit of the sun or the lower limit
Yeah,
of the
it's
sun?
it's from the same calendar, bro. Like 1 day, it doesn't matter what definition he uses. 1 day cannot change an hour and 17 minutes.
He's got to use the same definition on both days.
Okay,
in
the
both
definition
locations.
is the sun is above the horizon. I just told you. If the
can you
sun
show
is
me-
above the, dude, it's in the chat at 10:15. If the sun is above the horizon on day 1, check it out. On day 2, it would have to not be above the horizon for it to not be a midnight sun. So if he's got 24 hours of day on day 1 with a midnight sun, and he's got 22 hours and 43 minutes on day 2 with not a midnight sun, there's no way you can make up for an hour and 17 minutes. Using twilight would actually extend it, not make it shorter. So like that doesn't help you here.
Using twilight creates a big margin of error.
He's not using twilight, and twilight makes days longer, not shorter.
All right. Thank you for the back and forth. Seems like we're not going to be able to get anywhere on that one. Well, we've been streaming for about 2 hours now, a little over 2 hours. So we're going to go ahead and wrap up now. If anyone has any final closing thoughts, go ahead and state them now. And then we shall reconvene next week. So next week, we'll be moving forward with the null hypothesis series. That'll be the primary Monday stream event. So I'll link some null hypotheses, excuse me. I'll link some null hypotheses to you lads here from the null hypothesis section. What we're going to be opening up with next week is, of course, Battle of the Beams. So I recommend that if you want to participate in the conversation, you do some Battle of the Beams reading, maybe come up with your own stuff, or maybe formulate your own null hypothesis or something. The idea here isn't to just be the one presenting all the null hypotheses. Globers and flat earth lads alike can add their own null hypotheses, and then we'll go over those towards the end of the episode. And then maybe next week we'll see if if any of them were refuted yet, or what kind of stuff goes on with that. And as we go through and do episodes, I will add a section here for user submitted null hypotheses, and we'll keep track of all that stuff, and we'll just see how it goes as we lay some of these out, and we'll try and get some conclusions to some of these arguments that have been ongoing. So we got different categories. So here, this would be for horizontal beam propagation over a curved surface, whether the field strength would be receivable at these distances. And then we have, cosmological dynamics. So were any mutually exclusive gravitational values or masses used for, plotting Artemis's trajectory? We have, was Neptune truly discovered through Newtonian dynamics, etc. So we have different null hypotheses that we're going to be going over at different episodes. So the way the format will work is I will do a brief presentation, excuse me, at the beginning of an episode, and then we'll discuss. And it'll be unlikely that someone will actually refute it on the first episode or whatever. But should that happen or whatever, that'd be pretty awesome. But so we'll go over it, and then we'll touch back on it next week after we present the new null hypothesis for whatever it is for that week, and then we will go over that, and then we'll recap for the last week stuff and see if if there is any updates and whatnot. So I think that's how that's gonna work out structurally. So tune into that. That'll be hosted here every Monday at 8 p.m. Eastern, and that's 6 p.m. Mountain and 5 p.m. Pacific. So tune into that. Should be a great time. And like I said, get familiar with these ahead of time. And we're going to open with Battle of the Beams. So I'll try and have what we're going to do the following week ahead of time so that people can read the specific ones, because there's a lot here. So yeah, just go over the material and we can all have productive conversations about them and whatnot. So tune into that next week. Thanks everyone for tuning in. Much appreciated. Everyone enjoy the old conceptual model. I will add some of the stuff that was suggested here tonight, in particular, how to derive the area of a square on here. That'll be interesting to see what comes out with that. So we'll continue on. Thanks, everyone.
Thank you.